All right, a big part of what we're doing here is using derivatives to understand what's happening. So when I have a problem like this, and it says at the very top there, a particle moves according to the law of motion, S equals f of t. And S is the distance, and it has an output based on what t time it's put in, okay? And t is measured in second, S is measured in feet. So guys, if you picture a graph, and you don't need a graph, okay? But this is in feet, and this is in seconds for units, and I should have S up on the unit axes, okay? Here's what I want you to realize. I'm plotting some points, whatever, okay? The velocity, the tangent line at any point is going to be the velocity because it's going to be feet per second. All right, and that's the big thing we want to remember about calculus and derivatives here. When I have a position function, the derivative of position is velocity. So look at that. It starts right off with find the velocity at time t, and we are given a position function. So letter A on this problem is simply to find the velocity. So S prime of t is v of t. All right, and that's what I have to find. Now, we look at number 6, and I want you to see that it's the square root of t times a trinomial, right? Everybody, you could do the product rule. You could. I don't think I want to. I think there's two ways to do this problem. I am more tempted to distribute the square root of t and write this as 3t to the 5/2 minus 35t to the 3/2 plus 90t to the 1/2. And I just distributed the square root of t as a rational exponent to all those. And then to find the velocity function, then simply take the derivative of that, which I think is fairly simple. Bring the 5/2 down, I get 15/2 t to the 3/2 minus 3 times 35, last I checked, that's 105 halves t to the 1/2 plus 1/2 of 90 is 45 t to the negative 1/2. And everybody, I just found the velocity function at any time t. All right. So if I want to know where it's at in position, I would plug into this function for time t. And if I want to know what its velocity is at a given time, I'd plug into S prime or v of t, which is given by that function, which is simply the derivative. All right. And the units here on the position function are feet. The units on the velocity function would be feet per second. So then it says, what is the velocity after 3 seconds? All right. Velocity at 3 seconds is simply v of 3. All right. And I think I want a calculator for this one. Do you guys agree? Because there's nothing clean about this. And I can bring that t to the negative 1/2 to the bottom. I can just plug in 3 as time. And when I calculate this, I am simply going to get a value. Now, what are the units? The units on this should be feet per second, or FPS. Okay? So I'm going to pause the video, grab a calculator, get that answer. All right, so my calculator, and I'm going to go 4 decimal places because that's good habit. Negative 25.9808 feet per second. It's negative. So what do we know about this at time equals 3? What do we know about the particle? It's going backwards, right? Its velocity is negative. It's going backwards. All right? Letter C on this problem. So now we've done A and B. All right? And I'm going to group this up. I don't think I'm going to need this stuff. I'll remember that at 3 it was negative. I'll group it up. I'll just bring it up here. I'm probably going to need the position function and the derivative function velocity here. So C and D are really tied together. When is the particle at rest, and when is the particle moving in a forward direction? Well, particle's moving in a forward direction when the velocity is positive. And the only place to find the regions here would be to find when this is 0. Everybody, I'm not real interested in trying to factor this out, I don't think. Though if I pull out a square root of 1 over square root of t, if you had to do this without a calculator, if you pull out 1 over t to the half, all right, you would get 15 over 2 t squared minus 105 over 2 t plus 45. All right, and I don't know if you see that. I pulled out t to the negative half out of each of these. All right, and you know, you can tell again by redistributing it that it matches the one before. And right away you notice that you can't have t be 0, right? Because that would be undefined for velocity. But the other thing I notice here is I don't know if it factors or not. I think what I would probably do is put this in my calculator to solve it. I'm not that interested in doing this problem. So again, I would grab my solver, type in that function under math, and on my TI I would use the solver P, and I would just type in the function I had, 15 halves, and I'll plug it in and I'll get a solution here. So there are times I feel really good about the math I do because I type this in my calculator, and I tell it I want VT equals 0, so by TA84, my TI84 just spit out that t equals 6 seconds. Exactly. All right. So, man, I'm feeling pretty good about this. Now, maybe on my calculator, I take another guess, guess maybe 12 to make sure I'm not missing a second 0. I could graph it. I got 6 again. I'm not going to worry about it. I got 1. So I will tell you that the particle is at rest. Velocity is 0 at time equals 6. So then it says, when is the particle moving in a positive direction? From the previous problem, I knew from B that it was going in a negative direction at 3. If we agree that this root function is continuous everywhere for t being positive, and it is, right? That's why we learned about positive functions. Then the intermediate value theorem holds, right? If it's going to go from negative to positive, it has to pass through a 0 at 6. So it's moving negatively below 6. The only question is, does it just go 0 and then go negative again? So if I'm going to see if it's positive, I'm going to have to plug in a value greater than 6 into that function, right, and see what I get. So maybe I do V of 7 for letter D. All right, maybe I take my calculator and I literally just plug in V of 7. All right, so and the nice part about the TIs is you can use the second entry key at this point, right? Because we did it, or we already did it for 3. So I just got to go change my 3 to a 7 in 3 spots in my calculator. 7, lucky 7. 17.0084 feet per second. Do I really care what the value was? No, I just cared that it is positive. All right. So when is it? When's the particle moving forward? Particle moving forward when V of t is greater than 0 at interval time, I would just say 6 to infinity. You guys agree? And we just did letter C and D together. When's it 0, 6? When's it moving forward? 6, not 6, but 6 forward. All right? All of that happened through all these steps. All right? Now the last thing, and also usually the most difficult thing, find the total distance traveled in the first 8 seconds. All right, there's a couple ways to do this problem. All right, and I would much prefer to do this as an integral now instead of a position function. We could figure out using the position function, okay, times 0, we plug in 0 for the position function, and we get s of 0 is 0, okay? If you plug 0 into this function, all right? And then you can say, well, I know it goes backwards all the way till when? Till time is 6, right? So I could find S of 6 and see where I get to. And then they want to know the total distance for the first 8 seconds, and I could get S of 8. And I could get those two values. And we know distance can be calculated in these two spots, all right? So we could do that. So let's try that. I'm going to have to figure out, the calculator is going to have to tell me what's going on. 3, 6, and then make sure you're using the right values here. We're using the position function right now. Okay, we're using the position function, not the velocity function. And I get that it's negative. Over here, I get negative 29.3939 for 6, okay? 3, 6 to the 5 halves minus 35, 6 to the 1.5, 3 plus 90 times 6 to the 0.5. And if I do it again, but this time I just change the 6 to 8, right? So I want to know the position there. And I would expect this to probably be positive now, based on the change of velocity, okay? I get 5.6569. Everybody, you got to be careful. The position at time 8 is 5.6569. That is not the distance traveled in the first 8 seconds. That particle starts at position 0, goes backwards 29.39 feet, and then it goes from negative 29.39 feet all the way to positive 5.65 feet. So what we have for distance here, all right, I think it's the absolute value of negative 29.39 feet, right, plus the absolute value of the difference of those two, negative 29.3939 minus 5.6569. All right. So literally, our position function tells us that we get, or the other way to think about this, the way I think about it when I'm doing this, is it goes backwards 29 feet, comes forward 29 feet, and goes 5 more feet, right? Can you picture that in your head? And maybe that's easier. And I get a position here, a distance of 64.4447 feet. All right. Is there a different way we could do this? This is kind of the old school way when we were doing these problems back. But now that we know integrals, is there another way we can think about this? There is, right? And your calculator will do this for us quite a bit, all right? And I'm not going to draw the diagram. The diagram is, right, it does that. From time equals 0 to time equals 6 to time equals 8. 29, negative 29 feet, positive 5 feet. That's the diagram. The last thing I want to do is, couldn't we do this another way? And your calculator will give you total distance. Your calculator will do this integral for us. Because, guys, we can integrate S of t. Think about this. Can't we integrate velocity to get position? Absolutely, right? Fundamental theorem of calculus. And if I want the total distance, we can do it as an absolute value. So if you were to enter this into your calculator, guys, from 0 to 8, and you did the absolute value of this function in your calculator, v of t, dt, you will get what? The same answer we got before. You should get 64.4 feet approximately. And again, I have some rounding errors. You guys agree? Your 4 decimal places might be a little different than mine. You want to do that? So we can pause it here. All right. So if you want to enter this, we can enter this in our TI. I can tell it that, hey, I'm going to push math, right? And I'm going to do an integral, right? Which I know is getting a little reflection back. Let's see if I can get the reflection to stop. And there it is, right? And we know we want to go 0 to 8. You guys agree? And I got to do what? Well, I'm telling you now, I want to 0 to 8. Is that an 8? I guess it is. All right, and here I want to tell it to do absolute value. So you push math again, arrow over the number, arrow down to absolute value, hit enter. And you notice it put in the bars for absolute value. And now I just got to enter the function down here, the 15t to the 3 halves. So you guys agree 15 halves is 7.5? I'm going to have to use x because I don't have a t. Raised to the 3 halves is 1.5, right? Oh, is there? Oh, I'm not doing t. We're doing x. Minus, no. 105 divided by 2 is 52.5. X, I think I might x to the raised to the 0.5. And then plus 45. X raised to the negative 0.5. You got to tell it what to integrate, right? dx in my case. And it's really thinking hard here. All right. As long as I've entered it correctly. And what the calculator does, guys, it doesn't do the integral. It actually sums up all the rectangles. All right. So the more complicated the figure, sometimes the longer it takes. All right. We'll let it pause while we. And again, this will give you the distance traveled using the absolute values. All right. Keep practicing.